We are gonna solve three problems with similar ideas. First problem, this problem, A and B are real numbers. 8a plus 27b equals 10, 4 to the a plus 9 to the b equals 7. And we want to find A and B in next problem. It's for AMC 10A Fall 2021. Again, we have two equations, two variables. We want to find x and y. In third problem, that is from AIME 1 2021, we have one equation, two variables. We should find C's that satisfy one condition. Okay, if you want to prepare for AIME, AMC 10, 12, 8, or other math exams, if you want to learn important ideas in each topic, combinatorics, algebra, number theory, and geometry, feel free to send message to my WhatsApp number in the description. Okay, let's solve first this problem. A to the a is what? Is 2 cubed to the a plus 27 is 3 cubed to the b equals 10. 4 is 2 squared, then to the a, 4 to the a, 9 is 3 squared to the b equals 7. In next step, we can do what? We can use power rule. X to the m to the n equals x to the m n equals x to the n to the m. So we can switch m and n here. By applying this rule in power rule, we can switch 3 and a. It will be 2 to the a cubed plus 3 to the b cubed equals 10. If you apply on next equation, 2 to the a squared plus 3 to the b squared equals 7. Now, we want to use, so look, this one was only for power rules. Now in next step, okay, in next step, we use changing variable. Okay, so idea 1, changing variable. So we define as 2 to the equals x, 2 to the 3 to the b equals y. So it will be x cubed plus y cubed equals 10, x squared plus y squared equals 7. Okay, and now we want to find x and y. And what's the property? 2 to the a is always positive. If you see the diagram, 2 to the a will be something like this. Or 2 to the, for example, x, in terms of x. It will be 1. It will be always positive increasing function. Positive, positive. So x and y are positive. When you have something like this, also it is useful in SMT. I can tell you as homework 1. One problem, if you search in my channel, one problem from Stanford Math Tournament could be solved with this. Another homework you can solve PMO. The last problem. Oh, first problem, PMO national level for Philippine. National 2023. Last PMO national level, Q1. This problem also can be solved by same idea. Same idea is what? We use another changing variable idea too. When you have something like this, you say, okay, product is xy, sum is x plus y. So now I want to solve this problem by applying P and S. Okay. We should use another identity for x cubed plus y cubed. At first, let me tell you easier one. We know a basic identity that x plus y squared equals x squared plus y squared minus 2xy. So you can say x squared plus y squared equals x plus y squared. Sorry, plus 2x minus 2xy. So it will be sum squared, x plus y is s, sum, and 2xy product. So from here we can say sum squared minus 2 times product equals 7. Now for first one, x cubed plus y cubed, we can say what? Identity 4. X cubed plus y cubed equals x plus y times x squared plus y squared, or we can write x squared minus xy plus y squared. X plus y is s, x squared plus y squared is s squared minus 2p minus xy minus p equals 10. So if we write these two equations, s cubed minus 3p times s 3ps equals 10, s squared minus 2p equals 7. So two equations, two variables. So try to find s and p first on your own. Okay, now we should use replacement. And here you say, okay, p equals s squared minus 7 over 2. And then we replace in first equation. So it will be s cubed minus 3 instead of p, right, s squared minus 7 over 2 times s equals 10. Now, to get rid of denominator, we multiply both sides by 2, so it will be 2s cubed minus 3s squared s cubed plus minus minus plus 27 times s. And you take 10 to left hand side, minus 10 equals 0. So we can say s cubed plus 21s minus, when we multiply by 2, this part will be 20. So when we take it to left hand side, negative 20 minus 20 equals 0. And here also it will be negative s cubed, because 2s cubed minus 3s cubed. Now we can negate all signs. So we can say s cubed minus 21s plus 20 equal to 0. Now in this part, pause the video and try to find all three roots of s. Okay, when the degree of a polynomial is 3, one useful way is to find at least one root and then factorize. Okay, so when the degree is 3, one useful way is to find one root. And here it will be what? S1 works if you check. S1 will be 1 minus 21 plus 20 equals 0. So because S1 works, so we can factorize. And one factor is S minus 1. So we want to create s cubed, so I place s squared minus s squared. Then I don't have s squared here, so I place plus s minus s. I want to create negative 21s minus 20. It will be minus 20 minus 1 minus 21s minus 20 times minus 1 plus 20 equals 0. And then we can say s minus 1. You can use quadratic formula for this, or you can factorize. If you factorize, it will be s minus 5 plus 5 minus 4. Then it will be s squared plus s minus 20. Okay, so s will be what? Okay, s can be 1 or 4 or negative 5. So let's write all possible cases. S is 1 or negative 5 or 4. Now, negative 5 is not possible. Why? Because s was what? X plus y. Here, x, y, and s we said is x plus y by using these changing variables. So x, y we said positive, so s positive, p positive. So we can reject this case. Now, p is what? P is s squared minus 7 over 2. So if we consider s like this, p is s squared. So here 1 minus 7 over 2 minus 6 over 2, negative 3. Again, this case is bad because product cannot be negative. For this one, product is what? 4, 16 minus 7 over 2. So it will be what? 9 over 2. Now, x plus y is 4 and xy is 9 over 2. So we want to find x and y, then we can find a and b. For this part, again, we use replacement. Also, we can use Vieta's formula, but with replacement, it's so much basic. Y equals 4 minus x, and if we replace here, x times 4 minus x equals 9 over 2. So if we expand 4x minus x squared equals 9 over 2. If we multiply both sides by 2, then it will be 8x minus 2x squared equals 9. And then if you take all things to the right hand side, 2x squared minus 8x plus 9 equals 0. Now identity 6, identity 7. For idea 7, we want to use quadratic formula. If ax squared plus bx plus c equals 0, then x equals negative b plus minus square root of b squared minus 4ac all over 2a. So here x will be negative 8 plus minus square root of b squared 64 minus 4ac minus 4 times 2, 8. 8 times 9, 72. So here we will see it's not possible. Because 64 minus 4ac, it's negative inside square root. We call it discriminant. So we don't have any answer for x. So this problem doesn't have any solution in real numbers. Okay, it was part 1. Now let's work on part 2. Okay, problem 14 of AMC 10. How many ordered pairs xy of real numbers satisfying the following system of equations: x squared plus 3y 9 and absolute value of x plus absolute value of y minus 4 all squared is 1. Okay, in these types of problem also we had similar problem in AMC 2023. One equation most of the time is better. Which equation here is better to work with to start with? Second equation. We can say absolute value of x plus absolute value of y minus 4 is what? Because this squared is 1, so it can be plus minus 1. So if we add 4, absolute value of x plus absolute value of y equals 4 plus minus 1. So 4 plus 1, 5, or 4 minus 1, 3. Let me check how many identities, how I told you, identity 7. Identity 8 is drawing the graph. So much powerful. Also in previous part for 2 to the x, we drew the graph, drawing the graph. Now here, I want to draw the graph for 3, for example. Let me draw this. At first, I want to draw x plus y, absolute value of x plus y equals 3. So, because if we have absolute value of x and y, let's first consider this quadrant. If x and y are at least 0, then x plus y equals 3. So, it will be a line with a slope negative 1. X-intercept, y-intercept will be what? Will be 3. So, this part 3, this part 3. Now, for example, this quadrant. X is less than 0, y greater than equals 0. So it will be what? It will be minus x plus y equals 3. Again, if you want to find x-intercept, y is 0, so it's negative 3. Y-intercept, x 0, so y is 3. So y 3 here to x negative 3. Similarly, if you consider other quadrants, it will be 2 lines. So it will be what? It will be a square. Okay, like this for 3. Now, for 5 also, we can draw a similar thing. Let me extend the axis, and for x5, it will be, for example, something like this. Like, let me draw like this one. And let me extend more. And by using pink, this one 5, x, y intercepts are plus minus 5. So here is 5, here it's negative 3, here is 5, -5, -5. So second equation, if we draw it, it will be this. Now, let's focus on x squared plus 3y equals 9. X squared, now we want to draw x squared plus 3y equals 9. We want to draw this graph, and it doesn't want to find xy equals what? It says how many ordered pairs. We want to find number of solutions. So we should draw this one. This is draw a graph of a parabola y equals 9 minus x squared over 3. And because x is negative, it opens down. The coefficient of x, x squared, -1 over 3. It opens down. And the vertex is when x is 0. Because when x is 0, it will be maximum. So when x is 0, it is y is 3 and it opens down. And if I want to find, so y-intercept is when x is 0, 3. If you want to find x-intercept, 9 minus x squared, 0. So x squared is 9, x plus minus 3. So it passes through these points, okay? So it will be something like this. It opens down. And how many intersections are there? 1, 1, 2, 3, 4, 5. So the number of solutions equals 5. Now let's solve next problem. Let's solve AIME problem, part 3. In this AIME problem, it says find the number of integers c such that the equation this has 12 distinct real solutions. Okay, so look, when we have, for example, a equals, for example, 2, then a is what? Plus minus 2. So here, I want to get, by this approach, you can get rid of absolute value. So inside this part, when absolute value of that is 21, so inside is plus minus 21. So we can say absolute value of 20 times absolute value of x minus x squared minus c is plus minus 21. Now we can add c to both sides. So it will be absolute value of 20 times absolute value of x minus x squared equals c plus minus 21. Okay. Now we can say what? Here we want to, again, we want to use same idea that was useful in previous problem, AMC problem. In AMC problem, we use what? Drawing the graph. We drew the graph and solved the problem. Here, I want to draw this graph. Okay? The graph. So, draw this graph and see, can you solve? Pause the video and try first on your own. Okay, let's draw this graph. So, we want to draw a graph of 20 times absolute value of 20 times absolute value of x minus x squared. First, I want to draw inside, okay, and then apply absolute value. 20 times x minus x squared. So, first we try to draw this for x positive. For x negative, it will be same because x squared won't change, and this one absolute value. So, we consider x positive and then we reflect it for x negative. So if x is positive, it will be what? It will be 20, x minus x squared. So it opens down, and the roots are what? X times 20 minus x. So it will be 0, it will be 20, and the vertex will be midpoint of vertex of this. It opens down. Vertex is this point, is midpoint of the roots. So 0 it is 10. So in 10 it will be what? 10 times 20 minus 10, 100. So it passes through this point, and it will be like this. Okay? It goes like this. For x positive, for x negative, we have same thing. Negative 10, negative 20, like this. It is what? Graph of 20 times x minus x squared. Okay, now let me draw absolute value. So because it is absolute value, so this part should be positive, and also this part. So let me draw. Here we should have something like this. Let me draw it a bit better. And this part should be positive. This part should be positive. Now the problem says what? And this thing is the same. We want to find for which C we have 12 distinct real solutions. So we know this part, we drew this graph equals C plus minus 21. So now C plus minus 21 will be two horizontal lines, okay? C plus 21 and C minus 21. We want to have 12 distinct solutions. So let me move it. Let's analyze number of solutions for each vertical line. If our vertical line is here, we have two solutions. If our vertical line is horizontal line is here. Let me draw it a bit better. It will be something like this. Okay. So how many solutions are there? 1, 2, 3, 4. If our horizontal line is here, no solution. If it is here, 3 solutions. If it is here, 1, 2, 3, 4, 5, 6. So we can conclude that if we want to have each horizontal line, if we draw, has at most 6 intersection with this blue graph. So when we want to have 12 here, we should have 6 intersections, 6 intersections. C is an integer. So we can conclude C plus 21 plus minus 21, both of them should be at least 1, because this part is from 1 to 99, okay? So we can conclude C plus 21 is at least 1, at most 99. And also C minus 21. For this part, if we subtract 21, it will be negative 20 C and 2178. C minus 21 is at least 1, at most 99. So C is at least 22 if we add 21, and at most 120. Now we should consider intersection or union of these two inequalities. Intersection means C should satisfy both of them. So C is at least 22, and at most, because when it is greater than or equal negative 20 and greater than or equal 22, C has to be greater than or equal 22, because when it is greater than or equal 22, it is also greater than or equal negative 20. And for this part, less than or equal 78 or 120, C should satisfy both of them. So 78. Okay, so number of solutions will be last one minus first one plus 1, which will be 56 plus 1, 57. so there are 57 answers for C, and our answer is 57. Okay, if you want to learn other ideas in this part, we worked on how many ideas? On 8 ideas. If you want to learn other ideas in combinatorics, algebra, number theory, and geometry, as I said before, feel free to send message to my WhatsApp number in the description.